transformations, we are getting shuffle right and shuffle right, and number of stages are increasing. This thing we have discussed, and today we are going into the repartition and coalesce. This is wrong actually. I type it like this. I'm not getting. Repartition is by transformation. Coalesce is the narrow transformation. Before going into this, let's check this PPT and we can understand. So when we are going for the narrow transformation, each partition of the parent RDD is used by at most one partition of the child RDD. We have seen that RDD is immutable. So if you are creating, if you want to do any transformation in the RDD, we need to create another RDD. So whatever the parent RDD to child RDD, it would be the only one time, like directly parent RDD to child RDD, we are getting the data. But whenever you are going for the wide transformation, multiple child RDDs would be there. So it is going to be shuffling. Suppose this parent RDD is going to be multiple child RDDs. This is nothing but shuffling. So this shuffling is coming for the wide transformation. Multiple child RDDs may depend on a single parent RDD. So this child RDDs may depend on single parent RDD. One parent RDD can go to multiple child RDDs. This is wide transformation. Due to this only, we are getting shuffle right and shuffle read. So this would happen in the wide transformations. Each partition of the parent RDD is used by at most of one partition of the child RDD. Suppose if I'm using map and filter, you can see that in RDD we are having right list or collection. In that 1, 2, 3, 4, 5 directly it is you can see here. This is the lambda function where we are using a plus 20. So whenever we are doing that, for this collection of RDD, 1 plus 20, 2 plus 20, it is directly giving this is parent RDD item and you are getting directly into the child RDD. So that is what the narrow transformation. But when you are coming to the wide transformation, you will get, now we will see that group by key and reduce by key. There we can see that how it is shuffling. And in the joins also, what happened? Two RDDs we are joining, suppose. So this two RDDs will go to the one RDD. This is narrow transformation. And when you are coming here, you will get one pair. It is directly going. You can see. If you are feeling like it is join, it doesn't mean that it always be a wide transformation. It is directly going to single transformation. Yeah, people will have that impression that whenever we are calling join means join is nothing but which is a wide transformation. That is wide transformation, but depends on the join, what kind of join we are using. So here the join, if it is going to multiple child RDDs, so that is nothing but wide transformation. Yesterday we have seen the map transformation. Map is nothing but we are having RDD items 1, 2, 3, 4, 5 like that. That list is mapped to by using lambda function. We are mapping everything to the each and every element. So first item will come and it will mapped and it will give into the output RDD. Second item third item. The second item, it will come again. It will go to the next like output RDD. Next third item, it will take step by step, like first one item, then another item, then another item. This is the map transformation. We have already seen this in the practical session. So before going to the data frame, some of the concepts are left in RDD. We'll discuss that and then we can go.
Yeah.
I'm having an RDD, and then if we need to see that the partitions in file, then it should be more than 128 MB file. I'm not having that large file, so as of now we can see in the sc.parallelize by giving the what Python collection.
Yeah.
So I'm having RDD and how it is grouping here, and then how it is giving into the number of files. Let's see this. So how many, what is the file size and block size? File size,
128.
yeah, file size divided by block size. This thing we know, that many partitions we will get. That many number of partitions we will get. in the RDD. By default, it would be 2 for the file.
File.
Need to check my laptop. Nothing is working. It's okay. By default, number of partitions for a file is, which is less than 128 MB, equals to 2. If it is more than 128 MB, then it is divided accordingly. So how we will create RDD? RDD equals to, we can create in two ways, sc dot parallelize, sc dot text file. Both we can have. Inside we will give the path. RDD equals to, for this text file we are having two minimum partitions 2. But if you are having more than the block size data, which is more than 128 MB, then we are having more number of partitions. More than 128 MB. 128 MB is the block size. Then only we will have more number of partitions. So RDD we are creating in two ways, sc dot text file and sc dot parallelize. So inside this, what we are giving? Inside this Python collection, anything, list or anything, Python collection, and we will give the partitions. How many number of partitions we want to do, that many number of partitions we can give. So this is what we have done till now. Now what is happening? It is going to take number of partitions here. RDD, any transformations, like any transformations you apply on that. What will happen in this transformation? Grouping of data will happen here. Grouping of data to how many number of partitions you require. Suppose I'm saving this as text file here. RDD dot save as text file. How many number of partitions it would be there? Suppose if I have given 4 here four partitions if I mentioned here, then it is going to be 4 parts, which are nothing but 4 files. If I told that to do 10 partitions, which is nothing but 10 files, that we need to understand. One partition is nothing but one file. So how many number of partitions we are giving, that many number of files are going to be stored here. If it is file, if it is Python list, it is different. But if we are talking about file, then you can have that many files here. So what we are doing here, we are increasing or decreasing number of partitions. Increasing or decreasing number of partitions. So this is the actual scenario, what's going on at the back end. That is fine. So first one is repartition we are talking.
Yep.
So what repartition will do? Repartition will increase and decrease the number of partitions. So both can be done in the repartition, increase and decrease the number of partitions. Second one, you are having coalesce function. Coalesce function is especially used for the first null, getting the first null value. But coalesce function only for decreasing. This thing we need to keep in mind. Only, this is the most asked interview question. Only for decreasing the number of partitions. How it will happen in backend, we'll see now. So to write this RDD, how we will write is RDD dot repartition. How many partitions you require, you need to mention here. Repartition. So I'm using get number of partitions to get this. You can see that. We will write the same thing in the I'm just using the same one. Start. So what happened in the repartition is entire, like whatever you have given, entire data would be combined over there, and it will do again the repartition. But coalesce, what it will do is it will adjust the nearby partitions. I'll give you here before this. Suppose if I'm having already partition data, suppose if in this I'm having how many partitions are there? 1, 2, 3, 4, 5, 6, 7. Total 7 partitions are there, and this I'm using 4 only. So I'm taking 1, 1, 2, 3, 4. If I said to repartition, do the repartition for this what list? This is 4 partitions I'm having. I told to do this as 10 how many? 7 partitions. What it will do is it will collect all this list and it will give it to the 7 partitions, like 1, 2. As we have seen that if you are not having data, it is going to give to
empty.
So it would be like that. It will give an empty. But what happened if you told to coalesce function to do this number of partitions? Coalesce function is only for decreasing, only for decreasing number of partitions. If I said do this to 2 partitions, what it will do is it will collect that and it will give it to, it will adjust the nearby partitions. It can't take 1 and 3 here. It can't take 1 and 4 here. It will adjust nearby partitions. It will take 1 and 2 and it can give it here. And it will take 3 and 4, it will give it here. So it will adjust nearby partitions. This is coalesce function. But in repartition, what it will do? It will recreate it. So in repartition, it will recreate the number of partitions. Means it don't adjust anything. It can print, it can take anywhere. So the partitions can be recreated in the repartition. In the repartition, the partitions can be recreated. But whenever you are coming to the coalesce function, it will print like this. Three and 4. So what it means, it in coalesce, it will adjust the nearby partitions. It don't recreate. But when you are going to the repartition, what it will do is it will collect all the collection and it will shuffle everything and then it will recreate it. So it never repartition, the name itself showing, right? It will do repartition again. So it will shuffle and then recreate. I can simply say that if you are having number of cards, okay, you know the cards, right? Playing cards.
Yeah.
Suppose if you are having number of cards, what will you do? You will take those cards and you will mix it again. You will mix all the cards again. And then again, you will distribute those cards to the players. This is what happened in the playing cards. So in the same way, repartition will shuffle everything. It will shuffle and it will distribute it. Like how you are doing the playing cards, in the same way, it will distribute everything like that. So that's what we need to understand, the difference between coalesce and repartition. Coalesce don't shuffle everything. It will give directly. That's what. The same thing here also. Repartition, it will recreate it. It will shuffle everything and it will recreate. Now it has started, I think. So coalesce will adjust the data. Repartition will recreate entire set of partitions. While recreating, shuffling will happen. Okay. It will delete existing partitions and recreate it. That is the thing. So it will delete the existing partitions. Today it is taking time. repartition will recreate entire set of data, entire set of partitions. While recreating, what it will do, shuffling will happen. Will delete entire existing partitions. Yeah. And recreate recreates. What is coalesce? Coalesce, don't delete anything. Coalesce will adjust the data. And repartition is Y transformation. Coalesce is narrow transformation. So whenever you want to go for decreasing the number of partitions, we'll go with the coalesce because it is a narrow transformation. For decreasing number of partitions, we will go with coalesce. Why here creating is not possible? Creating is not possible. Then if you have need for increasing the number of partitions, then we need to use repartition. Increasing is happening in the, even decreasing is happening in the repartition. What will happen if you use repartition or decreasing? The cost is going to be increased. Anyway, we are having coalesce function for that. That's why we need to use repartition only for increasing, but decreasing is also happen in repartition. Okay, increasing number of partitions, then use repartition. This is what oh. So let me create one RDD. I'm taking 4 partitions. Just create this. Now I have created RDD. And now what we need to do, we need to see both coalesce and repartition. Just I'm writing RDD dot repartition. Inside that, what I need to give? I need to give how many number of partitions it has to be. I'm just giving 2. Bloom dot collect. So let's try to understand this. You can, for decreasing the number of partitions, it has taken 2 stages, and it is shuffle read and shuffle write happened. This means this is Y transformation. This is a Y transformation. So when even for decreasing also, narrow repartition will take multiple stages to do this. So this is nothing but which is a Y transformation. Here you can see that when we did the repartition, when I have just checked this RDD, you see this, we are having 1, 2, 3, 4. So if you understand this, how the shuffling happened here, 7, 8, 9, 32, 45, 78. So it has taken 1 from this, 8, 9 from this, and 32 from this, 45, 78. So these two things it has taken here, and 1, 2, 3, 4, 5, 6. It is, so it has taken, because we have given two partitions. So it is recreating again, shuffling and recreating again. Let's check the same thing with the Coalesce function. Okay, so I'm just using print statement, print inside that RDD with Coalesce. Coalesce function. Now I just want to I need to write here. So how to write RDD dot Coalesce. So you have it directly Coalesce, and inside that I'm having 4 partitions here for this. 1, 2, 3, 4. If I wrote 5, will that work? Let me check. Because Coalesce function is to decrease the number of partitions. 5. And I'm just using glom.collect. Glom. So glom dot. Try to execute this. 1, 2, 3, 4. How many number of partitions I have given this? 5. But how many it is giving? 1, 2,
4.
3, 4. Even how much you give, it can't increase because it is adjusting the nearby partitions. And it is directly giving that. No change in the data. You can see it. Now let me give the same with 2. You can see here the difference. 1, 2, 3, 4, 5, 6 directly. 7, 8, 9, 32, 40, 45, 78. But here shuffling is happened. First partition is stored here and second one is different. Oh, it is 2. If I gave it as 7, repartition. Ours is like only
4.
4. 1, 2, 3, 4, 5, 6, 7. See, 10 partitions it was taking. Even it is leaving empty, but it is doing 10 partitions. This is repartition, but Coalesce, it is only for decreasing the number of partitions. And you can see whenever I'm just creating this for with 4, right? But if I create the same RDD with, what is that? Um, 6 partitions. So I have created the same RDD with 6 partitions. Let's check here both how it is shuffling. Coalesce function with 4 partitions. and same again. Let's see. 1, 2, 3, 4, 5, 6 partitions here we are having. Repartition, just taking repartition here. Both are same. I'm giving coalesce 4 and repartition 4. Let's try to understand this. You can see here no copy pasting is okay. So we can see here 1, 2, 3, 4, 5, 6, 7, 8, 9, 32, 45. Each is having 2 partitions. Let's understand here. When I did coalesce, it will, I'm saying this to do 4 partitions. So what it is doing, 1, 2, it was taking here, 3, 4, 5, 6, 7, 8, 9, 32, 45, 78. What it is doing, it was adjusting the nearby partitions. So if you see here, you are having these 2 partitions which are nearby. So it will take these 2 partitions and it will give into 1 partition. What you need to understand is it can't recreate anything. It will just adjust it. So if you are having nearby things, it will adjust that. It won't shuffle. But when you are doing the repartition, what is happening? You can see here 5, 6, 45, 78. 5, 6, 45, 78. 1, 2, 3, 4. 1, 2, 3, 4. And again 7, 8, 9, 32. 7 here, 8 here, 9, 32. What it will do is it will shuffle everything. It will make into one single list. From that, it will take repartition. So that is what. That's what. You understand? Any questions on this?
Like one question like how it will partition? Is there any algorithm will work?
It will partition at backend. So we don't know.
Okay.
The assignment and allocation, we can't check it. But for coalesce, it is adjusting nearby. What we need to understand is shuffling is taking place. Like it will shuffle accordingly. Suppose if I took, there is no particular algorithm. If I do the same thing again with here 4, right? If I do the same thing with 5, it would, you remember this,
Again
or I
shuffles.
can copy here. You are having this one. I'm just giving
Right.
4 only. One thing I can say that it won't repeat the same. 45, 78. It
Yeah.
it can give like this also, right? 5, 6, 45,
Yeah.
78, 1, 2, 7, 8. But it is not taking like that. That
Yeah.
is different. It is the whole thing will taken care by the work driver node to which where it has to be stored.
Okay.
That's what, because this there is no particular algorithm that we can understand. But
Okay.
only thing we can understand is if we are giving the number of partitions, it will shuffle and it will uh, give it
Give that.
again.
Yeah.
That's what we need to understand. So do you have any idea in key value pair data set?
JSON.
JSON or dictionary, right? We are having
Yeah.
all these things. Those it can give the key value pair. So now try to understand key value. data set. Like RDBMS, there are no columns or no metadata in RDD. Our input data is key value pair. So if you understand RDD, you don't have any metadata for this RDD. We just created a list, right? So
Yeah.
for RDD, we are not having any metadata or any columns are there, no. But the only thing allowed in RDD is like key value pair. So you can give one key and value like that. How you are having Python dictionary. Okay, in the same way you can give it. For this, we are having, if we are having key value pair RDD, we are having two things. One is group by key and another one is reduce by key. Group by key, which is a complex transformation which is nothing but wide. If you are having reduce by key, then don't go for group by key. Okay, group by key should not use always, which is very complex transformation, and instead you can use reduce by key. Group by key and reduce by key both work for the same concept, but you need to remember this. Don't use this for aggregations. Instead use reduce by key. So for group by key, it would be input would be the key value pair. Output also key value pair. How the normal data set looks. Suppose if I'm taking a collection, how it looks 1, 2, 3, 4. This way we are giving in the RDD, right? This is normal data set. But what is the key value pair? It looks like this. Any string value, if you are giving, you need to remember that you are giving in the quotes. Okay, you should not give directly. I'm taking RAM. This is a key and the value is 1. Again, Bob. This is a key and this is a value. Anything. It is not only the number. We can have Apple also in the second part. But the thing is, we need to have one key. For that, we are having one value. Yes. Suppose I'm having Rahman. This is a value. This is a key value pair data set. Whenever you are having key value pair data set, so here when you are calling group by key, the data group by key, this is a key. Ram, Bob, Rahman. This is the, let's take, so this is a key and this is the value. So whenever you are doing group by key, then it is taking these values and grouping accordingly. This thing you need to remember. Group the data based on key. Let's create one RDD. I use I'm just giving this sc dot parallelize just try to create B no, my side arrow is not working. Okay, 5. Just taking the same. 4. This is one is key and second one is the value. So I need to give more. Keyboard is not functioning. So sc dot parallelize, I'm giving the value, and after this, what I need to do, I can give the number of partitions also, right? I can give the number of partitions. Give another one. This is very small data set. Method object is not, because we need to give again this and that. It has created. Okay. So I have given the 4 number of partitions. 1, 2, 3, 4, 5. Okay. 4 number of partitions. So for this, if I use group by key dot collect, okay, RDD underscore key dot group by key function and then collect. So you can see this, you are getting an output. With B, it is some iterable concept, and with A, it has grouped A, B, C, D. So it has grouped, you can see it, but you are not able to see the data here whenever you are using group by key. Okay. Input is key value pair and output also, but which is iterable. What is iterable? Iterable is nothing but it won't print directly.
Okay.
So it won't print directly. What we are discussing, input is key value pair, output also, but which is iterable. So whenever you are using group by key, the input is key value pair and output also, but which is iterable. What is iterable? It directly won't print that. directly won't be printed. That is why we are telling not to use the group by key. Okay, so whenever you are using group by key, suppose if I'm using group by key, what I need to do is I can use, instead of list tuple, I can use, tuple, right? List,
Yeah.
tuple, and I can use set also. It is not like that I can use only list. Whenever I'm creating RDD, I can use tuple, set, list, anything. Any Python collection I can use. Okay. This thing you need to keep in mind. So this is somewhat complex topic. So let's understand. For example, if I have given like this, okay, if I have given like this, okay, list V I have given something to understand. And this is a value, list is the value, K is the key. If I have given like this, for K comma V in RDD dot group by key dot collect. If I give like this, I can see that. I can give here list or tuple or anything. Okay. Just copying and trying to execute this in the Databricks. What is the RDD? RDD underscore key.
Key.
Now you can see the data. I'm just mentioning K
Yes.
means which is nothing but I'm just assigning key value
Key.
and I'm taking value as list. So for B, I'm getting 5 and 4. For A, I'm getting 3 because you can see here B, I'm having 5 and 4. And for A, I'm having 3,
Key.
C, 8, D, 7. This it came. Suppose if I use instead of list, tuple. Just execute this. Tuple is nothing but what?
Is also
So,
collection with
yeah,
parentheses like
with parentheses, but tuple is not having any duplicates in that, which is mutable. List is not immutable. List you can take any, like you can change it, but tuple it won't change. Tuple is immutable. So tuple you are having 5, 4, 3, 8, 7. Even I can give the set also. This is a way how you can query the group by. If you use directly collect, you can't get it. So I gave set. Set will come in the flower brackets. Even when you are defining your widgets, you need to give that widget in the set, because set or dictionary only accepted in the widgets. We will see in the future that is. But you need to understand whenever you are using group by key, if you use direct collect, which is iterable, so you are not able to get that value here. So to get that value, what you need to do, you need to give it either list, set or tuple, the value, and K. So for K, V in RDD, just we are saying group by. This is a way where you can get you can see the data. But if you give like this, you can't see the data. Okay. Suppose, for example, if I'm writing for loop, okay, for K comma V in RDD key, dot group by key select. What we need to do whenever we are saying any for loop, we need to give the colon and then I need to print k. Okay, just execute and print k. And again for I in v, which is nothing but I in v. Values are I in v, print I. Okay, this is a way we can see each value. This is just for like whenever we are trying to print key values, it is printing. And inside that I'm giving for B, it is 5 and 4. For A, it is 3. For C, it is 8. For D, it is 7. We can give like this or like this to see the group by values. Two ways we can query. One is by using for loop and another one is by using the key value pair and we can collect. This is a way we can query the group by key values. Okay. Or another one for k comma v in RDD dot group by key dot collect. I'm just using print keys and again print values. Values is nothing but v. Let's check. It will print values. Values is or nothing but list, right? We are list. It's failed.
Not unpack and on it.
Failure happened because task 0 and stage 2 failed one time. Most recent failure. So this. But you can print like this also. But most of the part when you use this one, this is easy to see the data. You can get the key value base. Key value, whatever you want, a list or set or tuple, just give that. It will automatically assign for KV in RDD. So what are the keys we are having that it will take and values it will take by group by and we can select it. So my preference is not to use group by always. It is not.
If you remove the list,
No. The list should be there. Values list should be there. Without list, how it can?
Okay.
Because it is, you can see here it is a small data set. If I'm having values more than 5 or 6, then there should be one Python collection where you need to call it. So without list, you can't call that list or tuple or something you need to call. But okay, that's fine. We can do this in this many ways. So there is a mapping function we can use in the group by key. Just ask this. what it will say. Iterate and print for k in v grouped rdd.collect print case the same way before we have printed. It will take
Yeah.
in the same way. What happened here? Mm. You didn't mention that to me, right? You also just following. So this is, I have given different RDD here. That RTD is not having key value pair. You got keys B, values 5, 4, keys A, 3, C, 8, D7. Like this, you will get it. So we are having another map function. RDD. Again, the same mistake. RDD key dot group by just using some map values. Dot map values to list. You see here, right? Map values
Yeah.
to list. Dot collect. You can print like this also. But here is one beauty of map values, that is I can use sum also here. I'm using sum. Sum means all the values are summed. B9 you got.
Okay.
Let
Yeah.
me give this is very small data set. Repeat A. So this is summed against. All
Yeah.
the values are summed. So, okay, you need to understand. I can ask length of the list also. These are all Python functions. It is giving B2, A2, C1, D1. Length is 1 only, right? So let's summarize all. Instead of loop, you can use this. It will work on values iterable. Okay. If you are feeling tough to write loops and all, so you can write a single statement like this. RDD group by key map values. This function will give you, instead of length, I can give list. So it will give the values. But this many ways you can get the group by key function output. You can use for loop. You can use again for loop. Here print k and inside that print I. So it will come like this. And this is a way k list to be. So there's 3 ways you can get the values. But my preference will always go to this. This is easy to write. Just rdd dot group by key dot map values function. If we give, we can get it. And inside the map values function, we can get how many, like, let's try count. Count won't give or something. No, it is not there. It has to be in blue color. Suppose if I'm asking help, no. So if you want to check the iterables, you can check by using map function. It is giving the outputs and how to use and where we can use this kind of information we'll get here. So whenever you are not able to find anything, you can use help. Okay.
Yeah.
You have any doubts till now? Tomorrow we will see reduce by key.
Okay.
And after that, we will see one word count program by using RDD. Then we can move to data frames. Just try to understand the concepts. Nowhere we are using RDDs now, but for the interview purpose, we are learning everything. Okay,
Okay.
even you
Yeah.
are not able to practice it because you are not having community edition. In free edition, they have not provided you RDDs.
Yeah.
Just for the understanding purpose, you understand this. One more
Okay.
concept is there tomorrow. Tomorrow only we'll start data frames.
Yeah.
Okay.
Surely.
Yeah. Thank you.
Yeah. Thank you.